Welcome to the video on similar triangles. First, I want to say how good it is to kind of be back together um, in this kind of modified environment. At least we're making progress in the forward direction, even though we all can't come back together in the classroom at the present time. I know that Miss Andre and I are both looking forward to the time when we're able to come together as a class, and that'll definitely be something to celebrate. But in the meantime, we're going to keep on keeping on as best as we can, and that's via these video lessons. So let's go ahead and get started. Hopefully you've had some time to look back over your notes on pages 6, 7, and 8 on similar polygons because this lesson will expand and grow that idea to talk about similar triangles. So first, let me refresh your memory by reintroducing you to the symbol. That squiggle symbol means the word similar. And when we talk about similar triangles, we're talking about two triangles in which two important things happen. The first important thing is that all of the corresponding angles have to be congruent. And the second important criteria that needs to be met is that all of the corresponding sides have to be proportional. So let's go ahead and let's take a look at how we can use these two ideas to solve some problems. Now, the nice thing about the video, well, there's a couple nice things about it, really. You can watch it whenever you want to. So if 8 in the morning is not your best hour to learn, feel free to watch it at 8 at night or whenever you are able to concentrate. The other nice thing about it is that if I'm going too fast, you can always pause me, or if you miss something that I say, you can stop and remind me without having to interrupt the class like you would during a live lesson. So don't be afraid to take advantage of those things. Watch the video at a time where you can actually tune in and be focused, and feel free to stop and rewind if you need to if you feel like you missed something important. All right, getting into example 1 now. Notice that in this problem we're told that those two triangles are similar to one another. And I'm going to remind you that when two triangles are similar, two important things happen. The corresponding angles end up being congruent, and the corresponding sides end up being proportional. Since in this question we're being asked to find the length of the side, labeled with a D, we know that we're going to have to use this second criteria, the fact that the sides are proportional. So I'm going to ignore this one for the time being, and I'm going to focus in on those proportional sides. I'm also going to use my similarity statement to match up the sides that are proportional. Notice that in the smaller triangle, A and B are the first two that are named. So I'm going to get my highlighter and I'm going to go to that triangle and I'm going to highlight AB. Its matching or pairing side in that larger triangle is going to be DE. And likewise, side BC in the first triangle is going to match up or pair up with side EF in the second triangle. Which means that the bottom sides of these triangles will also pair up or match up, or the fancy mathematical term that we use for that is correspond. And that's going to be important because when I write my proportions, I want to make sure that I compare corresponding or sides that match up. So for instance, when I go to write my first ratio, I'm going to compare the green side in the smaller triangle to the green side in the larger triangle. And because I compared smaller to larger in my first ratio, then when I go to write my second ratio, I'm also going to compare smaller to larger. I'm going to compare red sides because if I look at the blue sides in the triangle, I don't have any side lengths, nor do I want to find any. So smaller over the larger for the first ratio, smaller over the larger for the second ratio. Now that I have my proportion, I'm going to go ahead and I'm going to cross multiply. So the first cross product is going to be 5 times d, and the second cross product going in the other direction is going to be 30 times 3. Notice that I put an equal sign between those. So 5 times d is equal to 90. And when I divide both sides by 5, I find that the value of d is 18. Remember, if I went too fast for you, just hit pause so that you can catch up, or even stop and then rewind if you need to replay. One interesting thing that I'm going to draw your attention to right now is that notice the relationship between 5 and 30, the first pair of corresponding sides. Notice that if I multiply the 5 times 6, I end up with 30. My second pair of corresponding sides, 3 and d, remember that I got for my value of d 18, and notice that when I multiply that 3 times 6, I also get 18. That's not by accident, folks. So there's kind of a nice little shortcut that you can always use if you notice that the sides in the larger triangle are a certain times larger than the sides in the smaller triangle. You can take that little shortcut and then use the proportion to check, or you can use the proportion to solve as I did in this question, and then use multiplication to check and make sure that you really do have the correct answer. All right, and moving on. You'll be happy to know that example 2 down at the bottom of the page, I'm going to omit. I am going to have you write the word omit right in here just so that if we're ever glancing back through your notes, you can see that we deliberately left that one out on purpose and not by accident. So once you've written the word omit next to example 2, let's go ahead and let's hop into page 10. And on page 10 in your notes, again, we're told that these triangles are similar to one another. And remember that when triangles are similar, we have two important facts we have to remember. We have to remember that the angles are congruent and that the sides are proportional. Since in this problem we're dealing with the measures of some angles, I know that the fact that I'm going to use to solve this problem has to do with the congruent angles. So the measure of angle C is 4x plus 30. The measure of angle G is 5x plus 10. And remember, the word congruent means having equal measure. So in other words, when they say that these angles are congruent, we know that their measures are equal. So in other words, that the measure of angle C is going to be equal to the measure of angle G. And notice that in my similarity statement, C and G match up or pair up or correspond. I know that they are indeed those matching angles. So I might even write that down, that the measure of angle C is equal to the measure of angle G. But I'm also told in the problem and in the picture that the measure of angle C is 4x plus 30, and the measure of angle G is 5x plus 10. So I now want to write an equation that says that 4x plus 30 is equal to 5x plus 10. I'm going to solve this by first of all subtracting 4x's from both sides. And then lastly, subtracting 10 from both sides, which leaves me with a value of x that's 20. And since the question asked me to determine the value of x, and I've done just that, I'm done. All right, let's go ahead and let's move on to example 4. This one says, in the accompanying diagram, triangle A is similar to triangle B. So again, when we have those similar triangles, remember that two important things happen. The first important idea is that the angles are congruent, and the second important idea is that the sides are proportional. So if I think about what are my corresponding sides, I have the 8, which is going to match up with that unknown side in this littler triangle. I have the 6, which is going to match up with the unknown side. Oh, sorry, 6 is going to match up with 3 in the smaller triangle. And then I have the blue sides, which are also going to match up. And I know that the smaller blue side is n plus 2. So part of the problem is that I could go ahead and write a proportion, but I don't have anything in the blue triangle that's in the larger triangle, the blue side, I have nobody that's going to match up with the blue side in the smaller triangle. I have the 6 and the 3 that I can match up. And I know if I wanted to, I could say this piece is 4 because 3 times 2 is 6. And now 4 times 2 is 8. But that really doesn't help me with these blue pieces. But notice that larger triangle. Notice what type of triangle it is. It's a right triangle with a right angle. And I know 2 out of the 3 sides. And anytime I know 2 out of the 3 sides in a right triangle, I can always use Pythagorean theorem to find the length of the third side. So I'm going to go ahead and I'm going to let this be C, or my hypotenuse in the big triangle. And I know that the square of the shorter leg plus the square of the longer leg is equal to the square of the hypotenuse. Or in other words, 36 plus 64 is equal to c squared, or 100 is equal to c squared, and c is equal to 10. So now I can go ahead and I can use the fact that my sides are proportional because I'm dealing here with a side length to set up a proportion. So I can either say n plus 2 over its corresponding side in the larger triangle 10. I can either use the green sides 3 over 6, or I can use the yellow ones 4 over 8. It doesn't make a difference because those ratios are going to be exactly the same. The important thing is, since I use small over the large for my first ratio, I must use small over the large for the second. So I'm going to use 3 over the 6. And again, I'm going to go ahead and I'm going to cross multiply. So 6, and I'm going to be careful to put that quantity of n plus 2 in parentheses, equals 10 times 3. On the left side, I'm going to use a little distributive property. And I find that the value of n is equal to 3. That one was tricky because we really had two steps. We had to do the Pythagorean theorem first in order to find our hypotenuse, and then secondly, we had to do the proportion. All right, let's go ahead and take a look at one more example. So in this particular problem, again, we've got those similar triangles. And remember, whenever you see similar triangles, you want to think to yourself that the corresponding angles are congruent and the corresponding sides are proportional. Since in this particular case we're being asked to find the missing sides, we know that's the property that we want to use. And again, when I go to match pieces up, A and B, or side AB is going to match up with side DE. Side BC will match up with side EF. And then the last pair of sides are AC and DF. So now my red ones are matching, my blue ones are matching, and my green ones are matching. And we're being asked to find here all of the missing side lengths. So I might call the missing green piece X and the missing blue side Y. I am once again going to do small over large, so I'm going to compare the red sides. 2 is to 8. And then it doesn't matter which pair you find next. I'm going to find the green ones, so equals 3 over x. And when I cross multiply, 2 times x is equal to 8 times 3, or 2x is equal to 24, and each x is equal to 12. And then I'm going to set up a completely separate proportion now to go solve for the blue sides. I'm still going to compare my red sides, 2 and 8, because I know those, equals 1 over y. So again, I just did the smaller red side over the larger red side equals the smaller blue side over the larger blue side. So 2y equals 8, and each y now is equal to 4. Which, if I look at this problem, kind of makes sense because 8 is 4 times 2. 12 is 4 times 3. And lastly, 4 is 4 times 1. Folks, it would be so much better if we could get together in person, but until we can, this is the best we know how to do. So thank you for your time and your patience and listening. And hopefully we'll be back at it together sooner rather than later. We miss you.